Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This is video number 2 of a video for 9 academic students who wanted some more help with the measurement question homework from a few days ago. When we last were in video number 1, we had finished up to question number 4, so here's question number 5. It says that the semicircle in the diagram below has a radius of 4 centimeters. What is the area of the shaded region? Okay. So this is an interesting shape, and again, what you should do is think about taking this semicircle away for a moment, and what sort of shape would you have? Well, I certainly see a rectangle, kind of like this, and on either side of the rectangle is a triangle. Ooh, like this, maybe, and there's another one like this, but turned the other way. I know I don't have to make it so pretty, but I like to. Oh no, I cloned. Do 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 do. Do 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 do. Ooh, pretty. Okay, so this is what I see. I see a shape like this, which is a rectangle and 2 triangles, and then someone came along and took a semicircle away from it. So I'm going to find the area of the complete rectangle plus triangle, and then I will subtract from it the semicircle. So let's talk about just the rectangle. So the rectangle, I need to know length and width. So area equals length times width. So what's the length of this rectangle? Well, I mean, when I draw down here, it's pretty clearly 4 plus 4, which is 8. What's the width of the rectangle? So this line here would be the width. So with this line here, so what is that width? Well, look at that circle. That semicircle has a radius of 4. So no matter where I draw a radius line, for example, this one, I'm going to have a radius of 4 centimeters. And if I draw that radius line here, you should see that that's also going to be the same thing as the width of my rectangle. So my rectangle is an 8 times 4, so the area is 32 centimeters squared. So now let's talk about the triangles. And of course, both triangles are identical. So to find the area of a triangle, I need base times height divided by 2. And of course, base and height must meet at 90 degrees. So we already talked about the height. It's the same as the radius and the same as the width of the rectangle. So we know that this is 4. So what would this distance be? Well, again, let's look carefully at the diagram. The whole distance across the bottom of this shape is 14. This is 4 and this is 4. So that means 14 minus 4, subtract 4 again, that I have 6 centimeters to go here and here. So this is 8, and I have 6 to be split here and here. Because of this symbol matching this symbol, I know that that 6 centimeters must be evenly split between here and here. So therefore, the base of this triangle is 3, and the height must be 4. So the area of the triangle is 3 times 4 divided by 2, which is 6 centimeters squared. And remember, there's 2 of them. So I'm also going to put the triangle 3 is also 6 centimeters squared, just so I remember that this is one triangle and that's the other triangle. So that means that the whole system is 32 plus 6 plus 6, but now I need to subtract the semicircle. So the fourth shape is going to be the semicircle, and again, that's half a circle. So the area of a semicircle is pi r squared divided by 2. So it's a circle divided by 2. And all I need to know is the radius of the circle, and we've looked at that a lot. The radius of the circle was 4 centimeters. So pi times 4 squared divided by 2. So in your calculator, round to 1 decimal place. So I get 25.12. So that means that the shaded area is equal to the area of the rectangle, which is 32, plus the 2 triangles, 6 and 6, minus the chunk that was taken away, which is the semicircle. So all together, and again, I forgot to round to 1 decimal place, so make sure I do that in my answer. So when I do this math, I get an answer of 18 0.9, and was it meters? Centimeters squared. So again, to find composite shapes, you find the shapes that you know about. Oh, I didn't mean to erase everything, whatever. So I knew about how to deal with a rectangle, I know how to deal with a triangle, and I know how to deal with a half circle. And so by adding and subtracting, we can find the area of what's called a composite shape. Excellent. So let's look at the next question. Two different stores sell coffee in cylindrical packages. The prices and dimensions of the packages from the two stores are shown below. What is the difference between the unit prices of the two packages? Express your answer in dollars per centimeters cubed. So I write this down because maybe I'm not sure what else to do, but I know I need to somehow compare dollars to centimeters cubed. And of course, when I write centimeters cubed, my brain says, oh, that means it's a volume question. And certainly you should know it's a volume question anyway, because when you buy a cylinder of coffee, is the coffee in the surface area, or is the coffee filling the entire cylinder? Well, obviously the coffee fills the cylinder. You don't buy a thin layer of coffee surrounding a bunch of air. That would be strange. So I have to obviously find the volume of these containers and then compare them somehow to their prices. So we'll figure out how to do that in a second. Let's start by finding the volume. So I'm going to call this I'm going to call this one A, and I'm going to call this one B, and that way I can be very clear about my communication. Let's find the volume of cylinder A. Now the volume of the cylinder, look on your formula sheet, is pi r squared times height. So what do I know? Well, I know the height is 10, and I know the radius is 5. So I know everything I need to find the volume of cylinder A. So 5 squared, the height was 10. So punch that into my calculator. 5 times 5 times 10 times pi. Oops, 5 times 5 times 10 times pi. And I get 785 centimeters cubed. So now let's do the volume of cylinder B. Again, pi r squared times h. And if I look at my diagram, I have both the height at 6 and the radius is 3. So pi radius squared times height. And then do that math. 3.14 times 3 times 3 times 6. I get 169.6 centimeters cubed. So now I know the two volumes. So what I'm supposed to do is I'm supposed to compare the unit prices of the two packages. Now, even without this extra bit of information here, you should remember that unit price, whether it's a volume question or it's a ratio question, unit price looks like this. Oops. So unit price, and I'm going to use green because green is my brain. Green means go. Unit price is when you know the dollar amount for one unit. So for example, if I bought a pack of 10 pens, unit price would be the cost I paid for one pen. In this case, I'm buying cubic centimeters of coffee, so I want to know the price for 1 cubic centimeter of coffee. So let's see what we have. We know that for cylinder A, I paid $39.95. That's the cost. Cost always goes on top. And that was for how much coffee? It was for 785 cubic centimeters. And I want to know how much it is for 1 cubic centimeters. So this is now suddenly a ratio question. So think about ratio as either a multiplication or a division problem. So to go from 785 down to 1, I must have divided by 785. And therefore, I need to do that to the numerator. So in your calculator, you're going to take $39.95 and divide by 785. And yes, you're going to get a weird decimal. That's fine. So I get this, $0.05, and I'm just going to leave it there. That means if I could somehow walk to the store and say, my good man or woman, I would like 1 cubic centimeter of this coffee, and if they could, if they were willing to sell me a cubic centimeter of coffee at the same price, then I should pay 5 cents. Of course, you can't buy 1 cubic centimeter. You would have to buy 785 cubic centimeters, and that would cost you $39.95. But this is how you do unit price. So now we have to do the same thing for cylinder B. And cylinder B costs $15.95. And that gave me 169.6 cubic centimeters. So I need to know, equals what that would be for 1 cubic centimeter. And again, ratio logic. If I divide on the bottom by 169.6, I need to divide the top by 169.6. So in my calculator, that gives me, ouch, I typed something in wrong. Divided by, that gives me 0.09, which is 9 cents for a little cube of this particular coffee. So one of them is 5 cents per cubic centimeter, one is 9 cents per cubic centimeter. Obviously, the better deal is 5 cents. The question actually said, though, what is the difference between the unit prices? So the difference between the unit prices, so subtract. So one is 9 cents and one is 5 cents. So the difference is 4 cents. There. So a really good question because it had to do us doing not only volume, but also having to remember ratio math and how to deal with unit pricing. Nice question. Okay, let's look at the next one. It says Maria grows a variety of plants in a rectangular shaped garden. She uses fences to divide the garden into 16 squares that are each 1 meter by 1 meter. She also puts fencing around the whole garden. What is the smallest amount of fencing that Maria needs? Now, I know you're already looking down here at what I've got, but let me remind you, wake up your brain. Smallest fencing. Wait, rectangle. All of these words together should make your brain explode with the following word. Right? If I'm optimizing a rectangle, I need to make a square. And in this case, I'm optimizing the smallest amount of fencing, whatever, I know I need to make a square. Now, just in case you aren't trusting me about this whole square issue yet, I've actually got 3 possible choices for us to look at. Let's see how much fencing Maria needs for each of these. So if Maria was to make this garden, she would need 4, 8, 12, 16, 20, 24, 28, 32, 36. She would need 40 meters of fencing. Obviously, I could have just done 4 times 5 plus 4 times 5, etc., but whatever. Sometimes it's fun to count. Now, let's say that you don't trust me about the whole square issue and you made this garden. You would need 1, 2, 3, 4, 5, 6, 7, 8, 16, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42 meters. That's more. So what if you really didn't believe me about the square issue and you made this garden? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. 49 meters worth of fencing. Smallest, a square. Yes, indeed. We knew that, didn't we? Absolutely, we did. All right, so that is about enough time in this video. So that, I guess I'll meet you on video number 3 if you want to see the rest of these questions taken up. See you there.